So, you've all come to hear me talk about nested home labs, working smarter, not harder, doing more with less. My name's Sam McGeown. I'm a consultant with VMware now, even though everything else says extrovert. I'm now with VMware, working as part of the NSX practice. So I do a lot of NSX consultation. But today I'm going to be talking about automation in my home lab, how I use my home lab, how I make the most of some limited resources, because let's face it, not everyone has a full data center worth of resources to play with when they're learning stuff. So just out of interest, audience participation, who's got a lab, a home lab, and you use it for learning, active learning stuff? Good, good. My first bit of advice was to be, if you don't have a home lab and you want to get on in your career and you want to move on technically, get a home lab and learn in it. But it seems like most of you have already got that going, so well done. Step one's done. Okay, so you mostly know the answers to this, why have a home lab at all. Learn stuff free from risk, free from breaking production, free from getting fired. Also free from things like shared labs, co-workers. I tried sharing a lab with people before and it was a nightmare, because every time I tried to go back to something, someone had gone, oh yeah, we needed a bit more disk space and that VM you were working on, sorry, it's gone. Yeah, my own home lab, I wouldn't really bother working with anyone else's home lab anymore. And the other thing that, a couple of years ago I was here doing a session on, do you need a home lab? Can you do it all in the cloud? And I talked very eloquently and convincingly about moving everything into the cloud. The reality is that I use a kind of hybrid approach to that now. I do some stuff in the cloud and some stuff in my home lab, simply because flexibility. I can plumb things in where I want to plumb it in. Working with NSX a lot, I can make changes to the route tables. I can go to the physical routers and actually do stuff. So for me, the flexibility in my home lab, it still trumps the cloud environment. But I still do use cloud. I still run out of capacity very quickly and have to go and do stuff in AWS or in Ravello or something like that. So when you're thinking about a home lab, what do you really need? Obviously, being a VCDX, I go with the AMPRS. No, not at all. The factors that go with the home lab for me are cost, noise, power consumption, and temperature. You'll notice that there's a female in most of those. It's simply because the wife approval factor is the most critical thing. If I spend all my money, my wife will kill me. So the thing I always ask myself with my home lab is, do I really need it? Can I get away without it? What's the absolute minimum I need to do to be able to test this or to learn this? And simply from the point of view, you don't need high availability in your home lab. You don't need multiple redundant storage, backup, everything like that. Just treat it as a throwaway. And this is part of my argument around using nested labs, is that you can have an environment which is very basic, and you can throw away nested environments or spin up, destroy as quick as you like. I'm skipping ahead. So how do nested environments help? Well, for a start, they reduce the resource requirements. I can test out multiple versions of multiple bits of software, loads of different combinations, just using my one home lab. I don't need to have the resources to run all of them. I can run them one at a time, bring them up, bring them down. Reduce instability, and this is to do with the underlying hardware. When I was doing everything on the underlying hardware, I was add-ons to vSphere, removing add-ons from vSphere. You'll find that vSphere doesn't particularly like it. You get artifacts left over. You make changes that you forget about, and then you come back and something is broken because you disabled a service doing one thing, and then you want to do another thing. And so for me, having like a steady baseline underneath, just a plain vSphere environment, which is basic as, and I keep it reasonably up to date, but not bleeding edge, because I can do my bleeding edge in a pod. Again, reducing dependencies. If I've got NSX in my physical and then I want to try out NSXT, I've got to then figure out, well, how are they going to coexist together? They can, but you've got to figure it out. It's a bit more complex. If I want to do it in a nested environment, I spin up a new environment and shove in NSXT on top of that. Reducing costs, I don't have to buy a whole load of new hardware all the time. I can basically, as I keep saying, by reducing those resource requirements, I can keep my costs low, which, as I put in the previous slide, keeps the wife happy and therefore me happy. What it doesn't do, it does increase complexity, so it does make it a little bit more complicated. You have to think about things a little bit more because you've got different levels of nesting. Performance, you're not going to get hardware performance, but then it's a home lab. What are you actually testing? Are you doing performance testing or are you doing functionality testing? And for me, it's almost always functionality. I very rarely need actual performance, aside from me getting a bit bored going, doesn't really affect anyone. There's no customers who are going to get upset that it took me 40 minutes to spin up an environment instead of 10. Bragging rights. Well, we all know someone who might have a very large home lab who loves to tweet about it or loves to tell you how big their home lab is. You don't get bragging rights from nested environments, but there you go, you don't really need them, do you? So the building blocks for a nested pod, I describe it as an inner lab and an outer lab. The outer lab, all you really need is an ESXi host, one host. You can get away with a workstation. You can stick VMware Workstation on it and actually get away with just having a single host. And on the inside of that, you can build as complex as you like. You just need some cores, some RAM, and some storage. The performance thing, basically, the areas to spend your money on are the RAM and the storage. If you can get SSD and RAM in, and then more RAM, you're happier. And the SSD helps with the nested environments as well. And then what I describe as the inner lab, well, I typically spin up a vCenter server, some ESXi hosts, some shared storage, NSX, and then some VMs for testing. And that typically covers most of my use cases. I might have, on the outer lab bit, I might have a VRA instance that sits there and I can use to orchestrate the inner lab instances. But basically, those are the building blocks that we go with. And then you can see which relates to a physical environment, a virtual environment, and then a nested environment on that little diagram there. But it's just there because the slide looked boring. So, for a vCenter, I typically will always use the vCenter server appliance. Nobody wants to be messing with Windows licensing and spinning up and installing a couple of Windows, unless you're actually testing something to do with that. But I can automate a vCenter server appliance installation very, very easily. It's small, so 2 CPU and 10 gig of RAM for the tiny appliance, but actually you can reduce it, you can stop some services, some stuff that's not often used, and just to get core functionality, you can reduce it to 6 gig. One of the things that I had is I use NUCs, old NUCs, like 5 years old now. They got 16 gig of RAM as max, and running a 10 gig VM on them, they just don't like it. So what I've done is split out the PSC and the vCenter into two appliances, and then you can actually consume a lot less RAM and have smaller blocks for DRS to move around and things like that. So yeah, splitting them out. My vCenter runs 7 hosts, 7 physical hosts, and that consumes 1.4 gig of RAM doing that, and that's doing all sorts of things with all the services enabled. And then the PSC, that virtually does nothing from a day-to-day basis. It's only when you're using it for authentication, so it's consuming less than a gig of RAM. For the ESXi, I always use William Lamb's OVFs. He's got a brilliant library, content library, that you can just pipe into your content library on your outer lab, and that will download OVF deploys for nested ESX. It's got all of the tweaks and all of the settings that you need in there. It's perfect for doing that. It makes life so much easier. It's right-click, deploy from content library. Typically, you need a minimum 4 gig of RAM, but actually in practice, if you're doing anything extra, you're doing vSAN, if you're doing NSX, you need to have more RAM. That doesn't mean it's going to consume it. It just means that you'll hit problems if you have less than about 6. You need to configure the networking, so the VSS or the VDS on your outer physical host. You need to use promiscuous mode and forward transmit. That's because your nested ESXi are going to be spitting out multiple MAC addresses, and it won't be able to. The VMs won't be nested VMs won't be able to communicate unless the outer VDS can learn those MAC addresses, which means you need promiscuous mode and forged transit on. Also, from a performance point of view, there used to be something called the MAC Learn DB filter, which helped with the scalability of the MAC tables. There's a new version of that called the ESXi Learn switch. It makes a big difference in nested environments, especially if you're doing a lot of NSX or other networking, complex networking in a nested environment. So I recommend grabbing that and installing that. It's not a straightforward install, so there's a few steps to it. So William Lamb's nested Learn switch install documents there. So for shared storage, nested vSAN is what I tend to use. Main reason being it's self-contained in a pod. I can spin up a pod with some SSDs, fake SSDs, and all of the pod is contained within that one folder in my vSphere. And if I throw it away, it doesn't affect anything else. Nothing's shared with anything else. Makes it very useful. It does mean your hosts consume more RAM to actually exist. Your nested hosts. You can use an NFS server, so like a appliance or something like that that's running. Again, that's self-contained in a pod, but it's a little bit more difficult to automate, and I tend to find that it's less performant than the vSAN environment as well, nested vSAN. Finally, you can use outer shared storage, so storage that you use on your network, maybe on a NAS or something like that. It's not contained in the pod, which can be an advantage if you've got like scripts that you want to persist from environment to environment or share across environments. But you kind of need to pre-provision it before you set up your pods. So from an automation point of view, slightly less useful. NSX, working with NSX, I deploy NSX in all of my environments. It can make it very complex. Having NSX, so a network overlay on top of a virtual network on top of a physical network, you can start getting into tricky situations very quickly. And also, if you install NSX on your outer hosts, the DVS, so the virtual switch, will filter for the port, the UDP port that VXLAN runs on. So you may need to tweak things. There's an API call to change the port for the nested VXLAN. But you're safer if you're going to do NSX to do it in a nested environment. You can't cause any issues. So the NSX manager is quite a hefty beast, 4 CPU and 16 gig of RAM. I've successfully run it on 1 vCPU and 6 gig. You might find that the interface with vSphere causes, when you're actually managing it, you might get a few bug outs and things like that, but it will actually work via the API pretty well. Controllers, again, 4 CPU, 4 gig of RAM. You only need 1, you don't need to go for the full 3 to high availability. And also, what you can do is actually, when in vSphere, you'll go in and you won't have the option to change any of the resources, but you can use either the host client or Workstation or Fusion to actually log onto the ESX host directly, not vCenter, ESX host, and then you can edit the VMX file so that the resources drop them down to 1 gig at one CPU, and that means that your NSX is running on 2 CPUs and 7 gig of RAM in total, which is much better than 8 CPUs and 20 gig. Edges, they're small already. They're 1 CPU, 512 gig RAM, 512 mega RAM. Nice and easy. Don't have to do anything with those. And lastly, VMs to run on top of your nested pods. Now, from a performance point of view, you want them to be as small and as lightweight as possible because typically I'll be deploying from VRA or something like that. So I want to get them as small as possible, lightweight. The best one I've found, and I've tried a lot of distros, is Alpine Linux. For me, it's easy, it works, and you can install OpenVM tools on it pretty easily, and it's less than 100 meg. So when I deploy on my nested environment, it doesn't take very long at all. One tip that I have is to create a content library in your outer lab. So if you've got vCenter managing your physical host, create a content library in that, publish it, and then subscribe from the outer lab to the inner lab. It saves a lot of time in pushing out templates and things like that to your nested environment. So from an automation point of view, I've said it before, the environments can become throwaway, and that's really, really useful in that if you can deploy a whole pod in 50 minutes, an hour, it actually makes no sense to persist nested environments for any longer than you're using them. You can deploy multiple ones of them, chuck them away when you're finished with them. So for me, new project, spin up a new pod, test it, chuck it away. New version of the software, spin up a new pod, do the upgrade, test it, throw it away. Any kind of testing, straight away, new pod. And the tools I use for my automation is PowerShell, PowerCLI, PowerNSX, and PowerVRA. And I'm sorry if I'm rushing through this, but the session's shorter than I thought it was, so I'm going to try and get some demo going on in a minute. But yeah, not much time. So you can see over here, I mean, I have PowerShell scripts which will deploy the nested hosts, vCenter, PSC, NSX, deploy the controllers, prepare the hosts, and get everything ready so that when I log onto that virtual machine, I've got storage, I've got compute, and I've got network, and I've got everything I need to test something. And depending on how my lab's feeling at the time, it can take between 50 minutes and an hour and a half. I have no idea why it takes longer sometimes than others. I was doing a deploy yesterday, and it took like 75 minutes just for the vCenter part of it, which has no rhyme or reason, aside from the fact that it knew I was doing a demo, and so probably would do that. So I'm going to switch to doing a demo. There's some links there on a lot of the nested stuff. What I'm going to do now, just do that for a second. So what I do from Here we go. Right. Let's see if I can drive this now. Right. So my pod deploy script, and it's up on GitHub for anyone who wants to. Anyone wants to do anything. It's driven by a JSON template. So I create copy a template, populate it with IP space, what I want to do, any resource changes I want to make, how many hosts I want in it, where the installer source is. So, for example, this is a source folder with all the appliances, the OVF in there. Got some hosts, assigning how much CPU and RAM I want to put into it. For vSAN, like whether I want a 100 gig disk or 200 gig disk, or how I want to do it. A platform services controller spec, a VCA SA spec, some licenses, how I want to configure NSX. So all of that's captured into a JSON file. And then the main script, the pod deploy script, it's got various switches. And the reason I've done this is because one of the ways I've written the script is to make it as idempotent as possible. That meaning that I can run it on the same pod environment. I can run it as many times as I like, and it shouldn't break anything. It should just build anything that's missing. So given that I'm working in a lab environment, I'll get deployment failures on a fairly regular basis for whatever reason. I don't want to have to blow it all away and start again. I want to be able to use what I've already deployed and push it out. So these switches allow me to deploy it on a stage-by-stage basis. So I can deploy the ESXi, then patch it, then deploy VCSA, then configure VCSA, license it, blah, blah, blah. Each step of the process broken down so that I can do it step by step for troubleshooting, and also to do it in an idempotent fashion. So I can run, if I run deploy ESXi once, it deploys them, I run it again, nothing changes because it detects that they're already there. I'm not going to go through line by line of code, but you can see that there's logging, so you'll get a deployment. My network connection has gone down. You'll get a deployment log, so these deploy logs. Got functions for managing connections to VCSAs. That was something I had to work on quite a lot because you're connecting to an external and a nested VCSA. You need to make sure you're connected to the right one. Otherwise, you do all sorts of weird things on your outer deployment. Parallel deploy of ESX hosts, so it'll deploy all three at once, deploy them as tasks, and then wait for those tasks to complete. That cut me down from like 15 minutes for hosts to 4 minutes for hosts, which was quite a nice performance gain. Configuring the host for vSAN, deploying VCSA, deploying platform service controllers. So it's quite a long script. It's pulling, every time you see $config, it's pulling info from the configuration scripts. So there are some limitations. Licensing is a bit tricky to get right. I'm still working on that bit of it. It kind of licenses it. Sometimes it fails. I don't know why. That's tricky. The bit that really irritates me and is really tricky is the configuring the VD switch. So walking a host from a VSS over to a VD switch is like a pretty standard sort of, stick one leg in the VDS, move the VM kernel over, stick the other leg in. It's really simple, but for some reason, I'll get two hosts do it and one host won't. I'm still working on that. I can't work out why. But there we go. So a few minutes left. In a truly Blue Peter fashion, I said it took me over an hour sometimes to deploy. This is the script running. So I tried it earlier, got so far, and then it failed to deploy. So it failed to deploy one of the ESX hosts, so I ran it again. It's detected that the ESX host already exists, and this one already exists, and then deployed the third one. And then it's got its running tasks, and it's gone through to 100%. Configured CPU and RAM. At the moment, it's deploying an OVF file. It says this may take a while because you don't really get much feedback from the tool. But if you watch the logging file that comes as an output of this, it actually pipes the output from the tool to there, so you can see that it's running. Now, what this looks like in my vCenter environment. So it was pod 203 that I'm deploying. So you can see it's done 3 SXI hosts, it's done the PSC, and if you look down here, the VCSA is being deployed. It'll be moved up into that folder in a minute. But in true Blue Peter style, here's one I prepared earlier. So this one's actually deployed all of the vSphere environments. This one is one that I've been working on running NSXT. So you can see I've got various components, NSXT, got KVM host, NSX edges, the NSX controllers, all running just in the pod environment. So from the point of view of not wrecking my outer lab, being able to use it all the time, having it ready, that allows me to have full control and deploy and test brand new software, learn it, get on with my job without having to wreck my lab environment. So I think we've got, is it 5 more minutes? So has anyone got any questions, anything that they want to see, anything they want to go over? Okay, so the bare minimum, the question is what's the bare minimum of hardware that you need to run it, and what do I have running it? So the bare minimum depends on what you want to do. But if you look at the figures for, say, running vCenter, you can get that running for about 6 gig of RAM and a couple of vCPUs. If you want to have nested hosts, then you can get away with 1 nested host to test some things. Some you need 3. So it really depends on what you want to test, how you want, and what you want to do on top of that test environment. Because obviously you want to deploy VMs, you need more storage and various things like that. What I have running is the cheapest CPU that I could find for my money. So back in the day, 5-6 years ago, I bought NUCs. So I have 3 NUCs, which were way more expensive for the resources, and I wouldn't generally do them again. But the newer ones, although pricey, they're quite a nice form factor. And then underneath, I'll show you my hosts. I bought a Dell C6100, which is their old cloud form factor. So it's basically a 2U chassis with 4 blade nodes in it, and each of them is running 48 gig of RAM. And the whole thing cost me about 480 quid for that. I put in old discs, and so there's vSAN running on top of them. I put in old discs and some consumer grade SSDs. Been running for a couple of years. It's not really caused me any issues. Maybe every now and then Simon will testify to a frantic message about getting more discs. But so I would say I can do anything pretty much that I want to do on top of those 4 hosts. But I think even that's overkill. I power that off at night time because it's like a hot air dryer. And I recently installed a smart meter and it tells me how much power it's costing me every hour. So it gets shut down when I'm not using it. So this one sits in my garage, and I drilled a hole from my office in my house and ran a shotgun of Cat 6 cable, outdoor cable, down my garden along the fence to my garage, because it sounds like a jet engine taking off, and has 0 wife approval factor. That's the problem with cheap old hardware. If I had money no limits, I'd get some of the Supermicro stuff. I think it's the E200 series, their little form factor, dead silent. You can get a whole load of RAM and CPU in it, but it'll knock you back about $2.5 grand just to get one. So it's what your budget is as to how you can do that. Some people I know might run one of those in their office, but they're probably deaf as a post anyway because they're old. Yeah, so I don't know there's not really much else to say about those hosts. They are literally power hungry, noisy, horrible things that you wouldn't want running in your house unless you're mad. Yeah. 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 A lot of bang for your buck with those, but you obviously pay for it in noise and angry wives. Yeah. Yeah. So I can't remember that. I think I might have published one on the blog on how to use it. It should be pretty self-explanatory from hopefully the script's laid out in a pretty easy to read fashion, because I go back to it after 6 months and I've still got to read it myself, right? So I hopefully have written it in a way that makes sense. But yeah, I mean, you can always ping me on Twitter and say, at Sam McGeown. I'm on Twitter quite regularly. You can ping me and just say, look, I'm trying to do this. It doesn't seem to be working. Can you help? I'll try and help. But yeah, it's all up on GitHub. So my last slide was some links. Yeah. There you go. So there's a pod deploy script there, and that's got a template for the JSON as well. So you can copy the template, populate it with your own values, and it should just run. I would suggest running it one stage at a time. So like deploy ESXi, then deploy VCSA. So run the flags separately. There's some other stuff that I've done on there as well. So I did a script for doing the vSend to HA deploy. So 1 minute. Yes, there's a script there that you can kick the tires on HA. William Lamb obviously the granddaddy of this sort of stuff. He's got some great scripts out there. He's just released an NSXT lab deployment script, which annoys me a little bit because I was just about to publish my one. He's always there like a couple of days before me, which is really annoying. But yeah, a lot of my scripts are built on his earlier scripts and that sort of thing. You know, there's a lot of good stuff out there. So if you're just learning how to do it, just Google it. Someone's probably done it before. You can mash it about and put it in. Yeah, we've probably got time for like one more quick question if anyone. No more questions. Right. Thanks very much for coming and listening to me rattle on. Have a good rest of the day.